So we have a moving block having mass m collides with another stationary block having mass 4m. The lighter block comes to rest after collision. When the initial velocity of lighter block is v, then value of coefficient of restitution denoted by the symbol E will be, and these are the options. So in this question we need to understand two concepts. One is we should know that what is coefficient of restitution. Coefficient of restitution. Now it is denoted by the symbol E, and it is the ratio of relative velocity of separation to relative velocity of approach. Let's say of separation to relative velocity of approach. So we have two blocks, one of mass m and another block of mass 4m. Okay. Now initially this block is moving with velocity v and this block is at rest. Okay. Now the lighter block comes to rest after collision. Okay. So after collision this block is at rest and the block of mass 4m, it is moving with some velocity v2. Okay. Initial velocity of this block is v, but it is u1 represented by the u1. So u1 is v, this is u2, it is 0, and this is v1 is 0, and this is v2. Okay. So coefficient of restitution E, it is relative velocity of separation. So that is v2 minus v1 divided by relative velocity of approach, that is u1 minus u2. So with substituting these values, we have E is equal to v2 minus v1. v1 is 0, so minus 0 divided by u1 is v, and this is at rest, so minus 0. Okay. This is one condition. Now in all types of collisions, here we are having a collision situation. Now in all types of collision, whether it is elastic collision or inelastic collision, momentum is always conserved. So total momentum before collision is equal to total momentum after collision. So what is the total momentum before collision? It is m times v plus 4m times 0, because this is at rest, and this is equal to, now this is at rest, so m times 0, 4m times, this is v2. Okay, so this is m into v is equal to 4m into v2. So this gives v2 is equal to v by 4. Okay, so if we substitute this value over here, we have E is equal to v2 is v by 4 divided by v. So that is equal to 1 by 4 or 0.25. So among the given options, option 2 is the correct answer. So this is another question from NEET 2018 from the topic rotational motion. A solid sphere is in rolling motion. In rolling motion, a body possesses translational kinetic energy as well as rotational kinetic energy simultaneously. The ratio, this is kT translational kinetic energy divided by kT plus kr. kT is the translational kinetic energy, kr is the rotational kinetic energy. So we need to find this ratio for a solid sphere. Okay. So now translational kinetic energy, it is half mv square, m being the mass and v being the speed. Okay. And rotational kinetic energy, it is given by half I omega square. Okay. Now this is, I is the moment of inertia, omega is the angular velocity. The moment of inertia of a solid sphere, it is 2 by 5 mr square, m being the mass, r being the radius. Now omega square, omega can be replaced by v by r, so omega square will be v square by r square. So this r square cancels out, 2 cancels out, so we have 1 by 5 mv square. So rotational kinetic energy is 1 by 5 mv square and translational kinetic energy is half mv square. So substituting these values over here, so kT by kT plus kr is equal to half mv square. This is half mv square plus 1 by 5 mv square. Okay, so this mv square terms cancels out, and so we are left with 5 by 7. So this is the required ratio. So option 2 is the correct answer.